Hello, welcome. Thank you for joining us today for our webinar with the importance of thermal comfort in bedding. We have two very special guest speakers from Emma Sleep, and I'm really excited to introduce you to them both. They're great, and they have a great presentation prepared. I'm just going to give a really brief intro on C-Therm if you haven't joined us before, as well as some background on some terms that you're going to be hearing and using, so just so that we're on the same page. But if you haven't been to one of our webinars before, I just want to talk a little bit about C-Therm's purpose statement and who we are as a company. So our purpose statement is simplifying thermal conductivity testing for the materials of tomorrow. And we're based here in Canada, and we're one of the best companies for this, and we truly are world leaders in transient thermal conductivity measurement. A part of this kind of philosophy is that we really believe in having flexibility. When you're measuring thermal conductivity or any thermal properties, really, it's important to measure under representative conditions for your sample. And this can be really difficult when you're kind of pigeonholed into certain methods. A quote that really kind of exemplifies this that you may have heard by Abraham Maslow is, when all you have is a hammer, everything looks like a nail. So we kind of took this to heart and wanted to make sure that the sample doesn't have to conform to the sensor, but rather you have many different options for your sample. And we did this, if you saw the video at the beginning, by using Trident here. So this is our kind of main product, and you can see it's one instrument with three methods. The only one that you'll find with this, but we're going to really focus today on the MTPS, or the modified transient plane source method. It's that kind of silver one you see in the bottom right there. If you are curious about the other methods, not that they'll come up too much, but there is resources on our website. In particular, there's the method selection guides. This goes over not only those three sensors you saw previously on Trident, but a couple of other more kind of old school methods, kind of listing their pros and cons and their applications. It's a really great free resource on our website. Jacob just dropped a link in there now. But if you're curious as to, which your sample will be best suited to, this is kind of a great spot to go. So kind of why is it important to characterize textile materials? This is what we're going to be talking about today. Well, the thermal interactions between your body and the materials are really what dictate how you perceive temperature and the feeling of cool or kind of a warm feel in your clothes or your bedding that way. And there's many different properties that kind of go into this. There's, all different kinds of thermal characteristics. But one of the most important ones is thermal effusivity. So if you're kind of new to this term, it's going to be thrown around a lot, which is just why I wanted to provide this background. So what is thermal effusivity? Thermal effusivity, sometimes it's called thermal inertia, and simply it's a material's ability to exchange heat with another body it's in direct contact with. So you can kind of see in those diagrams there, you have two different materials touching, and it's going to determine how they exchange heat between one another. You can see in that formula, there's a way to calculate the interfacial surface temperature between two materials. And this is really going to determine how you perceive this feeling. So if you're touching something that bills itself as kind of cool touch, this is really where they bill it as. So it's used a lot in claims validation. You can see just a couple products we found that we're listing. You can see if you look in close, they bill themselves as cool touch or cool to the touch materials. And thermal effusivity is really what they're referring to when they use this kind of marketing language. So it really is kind of backed up by scientific properties, and thermal effusivity itself is governed by an ASTM standard. So you can see here ASTM D7984 for testing fabrics. And this diagram that you see on here is actually taken directly from that standard. It's used with the modified transient plane source, as I mentioned earlier, and you can kind of see the sensors represented by that figure labeled as 2. It's plugged into the controller and the computer, and it also has a compression test accessory on the top, which is labeled 5. So a couple of key factors that are considered with it is temperature and relative humidity. This is just a bit of background on how this standard works and what really needs to be considered for it. So like I mentioned, it's with the MTPS. The modified transient plane source is actually C-Therm's proprietary sensor, and it is the only sensor that conforms to this ASTM D7984. So that's why you're going to see it kind of come up a lot in this and other textile applications that you might hear. It provides both thermal conductivity and effusivity, and it's a really fast measurement. Like I mentioned, there's a lot more information in the method selection guide, but it really has quite the application for the textile field. I mentioned a bit earlier with the ASTM standard that compression was a pretty important factor when dealing with this, especially if you're trying to quantify your effusivity for claims validation purposes. And this is a really good diagram that we have just on why that's so important. So you can see there's kind of fiber and there's air voids in between them. And when you apply compression, this is going to reduce the size of those voids, and that's going to have a direct impact on the effusivity and therefore like the feeling that you're going to have on the material. So you can imagine if you're kind of pushing down on a material, the more you push down on it, the difference it's going to feel that way. And that's based on the change in effusivity caused by the less air voids. So just a quick example of this, you can see in practice here, based on the levels of force applied, the effusivity is going to increase as a function. So that's why it's really important to kind of control for that and test under those representative conditions, as I was mentioning. But this has been my brief intro. It's, this webinar really is going to be about Emma Sleep, and I'm really excited to invite Angela and Rogin on screen with us here. If you guys want to come up and share your slides, we're very excited to have this collaboration.
Hello.
Yeah, does it work?
Yes.
Perfect. I'll leave it to you.
Thank you so much, John. All right. So, hello everyone, and thank you so much for joining us. And John, thank you so much for hosting us and the introduction. So I'm Angela, and next to me is Rogin, and we are currently sitting in Frankfurt, and we work for the R&D team at Emma. And we'll take some minutes to walk you through the efforts that we put in understanding thermal conductivity and overall thermal properties of our bedding materials. So, as a company, Emma is a leader in sleep technology, and this is driven by the development of the excellent sleep products that we have. And many of them are, at this point, actually way more than 75 product awards that we have worldwide. And this is really rewarding because this means that there's many people actually in over 40 countries that we're present, both through retail and online through our web shops or marketplaces that we cater to really large audience. Now, the team actually, I mean, the whole company drives the success, and one of the big pillars is the test lab that we have at Emma. This is in Frankfurt, where actually Anna and Adam also have visited us last year. And Rogin spends a lot of time with his team testing the products, the different materials, and ensuring we provide the quality that our sleepers deserve. Now, beyond the mechanical properties and understanding, for example, durability and overall ergonomy, we wanted to push a little bit the boundaries and actually start understanding a further step, which is the thermal properties and basically the overall heat transfer that occurs in the bedding, the mattress that comes from the sleeper, and in the materials that go around it. And this is a very happy day over a year ago now, when we were so excited we even broke the policies of COVID, but we got in touch with C-Therm, and we started testing with Trident and started going through the building blocks of our mattresses and the rest of our portfolio. Now, before actually jumping into the thermal lab, I wanted to do a quick detour and start with me and you and everyone that sleeps, and give you a glimpse of how we came here to this topic. So basically, with a general rotation of the Earth, we also have some environmental changes, right, that occur in this more or less 24 hours. And I mean, an example would be how generally it is brighter and warmer during the day and colder and darker during the night. And our body throughout evolution has also adapted in a way that it has also these biological processes that actually take place in this period lengths of also more or less 24 hours. And one of these processes is also our core body temperature and the cycle that it goes through. So the core body temperature is basically the temperature we have in our organs, in our brain, and it has its own range at which our cells, our tissues, our organs function optimally. On the graph on the left, you can see more or less how it fluctuates during the day, with a peak happening in the early evening hours, and then we have a minima happening in the early morning hours. Please note that this is a very specific graph we drew. It looks very perfect. Of course, there's variations, and there's individual also variations of when these peaks and throws happen. But you get the idea, and I want you also to focus on the gray part that I have highlighted, which is more around, let's say, 12 a.m. And you can see the slopes, the temperature also reducing, right? So for this temperature to reduce, of the core body temperature to reduce, we have a mechanism, right, that supports this. And I want to introduce you to what helps in this thermoregulation, meaning this basically this process that happens in our body that ensures that our core stays within the optimal temperature, and also that ensures that in the evening we have this core cooling. All right. So basically, we have the skin. The skin is the part of our body that really gossips on the inside and tells our brain and our body what is happening on the environment, and makes sure that we survive and that we adapt to our environment. We either do behavior changes, or we have physiological changes that occur in order for us to survive and to maintain this thermoregulation. And something that is interesting compared to the core body that stays within a very narrow range, we actually have our distal skin, which is our hands and feet, that fluctuate quite by few degrees throughout the day. And then we also have another keyword here, which is the proximal skin temperature. This is our body trunk, our thighs, that is also has slightly lower, but also a more narrow range compared to our distal skin. Now, if we focus on our little eggy family that we also made for just to explain the process that happens, we have this difference in temperature, right, from the distal to the proximal skin, especially during the day. And I'm not sure where you are in the world right now, but you can also simply take your hand and feel the core, maybe your neck or your back, and you will notice there'll be slightly, your hands being slightly colder, maybe a lot more colder compared to your proximal skin. Now, what happens in the evening, we have this diminishing of this temperature difference. We have this distal to proximal skin gradient happening, meaning that basically the core cools down by your body shuffling a lot more of the warm blood to the skin surface in the hands and the feet area. What does this mean? This means that the warm blood, we have areas that are basically, there's a vasodilation happening, meaning that instead of narrow roads, we can say you have all of a sudden you have much wider highways that allow your warm blood to reach the skin surface and cool off, and then come back to the core, support the cooling down. And what you can see in terms of temperature, you can notice that basically we have this diminishing, as I said, in the temperature difference across the body. And this is really important. So we bring this up because this is really essential for sleep. So overall thermoregulation is important throughout the day and during the night. And just to emphasize what we mentioned so far is that we have on the left a graph that shows the core body temperature, how it cools down. And we have this gradient also becoming higher, distal to proximal skin gradient becoming higher in the evening. And this is essential because it's actually related, coincides and correlated to also sleep onset, where supporting this core cooling down and warming up of especially the distal skin, also with easier falling asleep and overall better sleep. Now, when you enter in your bed, you tuck yourself in and you have your mattress under you, have the bed cover, your PJs, your bed sheets, and of course the air temperature and the humidity, and all of these are very important factors for this bedding microclimate that you're setting up around yourself. So what we say at Emma is that we really want to make sure that we support this cooling of the core, and we want, but we also want to make sure that there are no shivering and people are not sleeping too cold and wake up because of that. We also don't want people to sleep too hot and then wake up in their own sweat pool and have again awakenings. But we aim to go towards this optimal temperature, and it's a long road. So we will show here maybe some baby steps. And I'm excited now to enter a little bit more into the part of our portfolio, which is mattresses, and how we try to understand and implement research and try then into understanding the fabrics and forms. Now, if we focus on mattresses, covers are actually the first layer that comes in contact with the sleeper. And when it comes to covers, we can compare and test different composition, construction, finishes that could enhance also the moisture management as well as the cool or warm feel and have a higher effusivity. And what we do here is on the right is you can notice how I mean it's it's very visual, but for example we were comparing the same cover with a specific finish, and then a colleague also wanted to show this and have the subjective feel and compare truly or see if people can also of course notice when we make this incremental changes in the products. Now, something interesting when working with covers is also this working towards the tactile perception and how we can also play around with the design. And I mean, the data on the left is not necessarily the fabric on the right. Is just to give you an example of how also within the same cover we can have also a different effusivity, difference in effusivities of over 100 points that was played with the construction. And what is interesting here is how one could approach this. We take into consideration, for instance, the end use of the product, the communication, and different parts of the cover that could be have dynamic feels, for instance. So that is one example. And of course, we complement this then with the moisture management performance, and this aids overall towards the end product and decisions. Now, enough about covers. I'll hand over to Rogin, our foam expert.
Thank you, Angela. So let's talk about forms. So forms are more than ergonomy. So I know most of us concentrate on the ergonomic of the mattress, but it's more than ergonomy. It's about the thermal comfort also. Of course, thermal comfort is something subjective, but still, we would want to emphasize on the thermal comfort. Now, there are different kinds of forms. We have a standard form, we have a memory form, we have hyper soft forms, we have high resilience forms. However, in this talk, I'm just going to talk a little bit about memory form, which is a major player in thermal comfort in bedding, so in mattresses. Now, memory form invented by the NASA in around 1960s, has been one of the major players in one of the major building blocks of mattresses. Why? Because of its pressure relieving properties. However, one of the major drawbacks is the thermal discomfort that this particular foam causes. So most of the memory foams that are being used in the mattress industry, they're closed cell. Now, consequence is that the heat builds up, moisture builds up under the sleeper. And of course, when heat and moisture build up, the person tends to wake up and of course, in a pool of sweat. So to overcome this, we thought about, okay, what if we start using open cell? So that was the first attempt that we did. So we bought a small breathability device and then we tested it and we started using this. However, we noticed that the thermal comfort is still not up to the standard. So this is when we contacted C-Therm and we invested in Trident. So the first step was to build our own knowledge. So for that, we reached out to all our suppliers in different continents, in different countries across the world. We asked them to send some foam samples. So we have around 200 samples here. We cut them all into small pieces. So as you can see, around 5 by 5 by 2.5 centimeter. And we started testing these foams at different compressions, so at around 20%, 40%, and 60%. So basically to mimic the foams or the compression of foam on mattress. Now, based on this result, we started noticing there are big difference between in thermal conductivity between different foams, whether it be memory foam, whether it be standard foam. And we started developing mattresses based on foams with higher thermal conductivity. And the consequence is that for one of the foam, one of our specialty foam, which is graphite infused open cell memory foam, we found out that the thermal conductivity is much higher when compared to a typical closed cell memory foam that's out in the market. Now, once we started using this particular foam, we noticed that the overall thermal comfort of the entire mattress suddenly it started performing much better, and our in-house testers, they started feeling much better and they started sleeping much better in these mattresses. So we thought, okay, maybe beyond this, what else can we use Trident for? So we started using Trident as an objective or to compare different materials, different products, different tires, different foams, and additionally, we started doing more research into the thermal properties of different materials because, of course, we have the tool now. And additionally, we also started using them as a tool to validate different suppliers. So we started giving them benchmark values, so where they can achieve this or how they can achieve this particular thermal comfort that we're looking for. And finally, also to do quality control or quality check on these products. So now we've established a storyline. You have an understanding how foams from such small sizes influences, or how from such small pieces we develop a product which is, let's say, at the end, ensures that our customers can sleep in the best possible thermal comfort. Of course, we still have a long way to go. It's just baby steps. We're working towards the best possible solution for our customer. We'd like to do a big shout out to our team at Emma. So whether it be R&D, marketing, anyone and everyone working at Emma, they've been a huge support, especially to our testers who've been continuously testing day in, day out, overall around 200 samples, just foam samples, and of course, I don't know how many fabric we've tested so far. Hours and hours of testing, and to our partners at C-Therm, Adam, Anna, Arya, John, thank you for your support. Thank you so much. Back to you, John.
Thank you very much. That was great. Really interesting, and I'm glad we had the opportunity to do that. If you guys could stop sharing your slides, I'll just do a bit of an outro at the end there. I might take some of the time that we have to go over some of the resources, but perfect. Here, I think I might actually need to share that one. Yeah, perfect. Thank you. Cool. All right. So I'm going to be putting poor Jacob to work if you look in the chat there, but we have lots of resources on C-Therm.com. So our webinars will be published with the recording as well if you don't just get that via email, or if you want to kind of spread that out later. But there's plenty of other webinars, textile based, other applications, if this is kind of interesting to you as well. We don't flag it perhaps as often as we should, but the tech library in particular is where we put any kind of published papers that reference C-Therm's technology. So we often kind of go and check what's going out there in academia and how is our sensors being used, not just the MTPS, but the whole Trident suite. And we upload them based on categories. So if you're ever interested in kind of, does someone have a similar problem as you? Would this really be a good application? This is a really good resource because it's peer-reviewed papers and it's kind of all in one area. So it's a great resource, and we do try and keep it updated. Likewise, actually, we have application pages. So if you go onto kind of the website, you can see the textile application, and we will put papers that get published that are really interesting using our technology at the bottom in the resources section. That's also where you can find conveniently any webinars, blog posts that we've done that way. So just a lot of really good resources. If you're looking for something, please, you feel free to reach out and ask, but there are plenty of places that we like to put our resources. We do have a couple upcoming events that some people from C-Therm will be attending. So just if you happen to be in the area and you recognize any of these logos, it might be great to reach out and see if we can arrange a meeting. We'll have a couple people from C-Therm going to the IME West convention in Anaheim, California at the beginning of the month. It's 5 different trade shows in one, so it's pretty interesting. It's a very big event. So if you're already in the area, please reach out. And we'll also be having someone going to Germany in Munich for the thermal management for EV Expo. I know it's kind of a different application than we have here, although there are plenty of textile fields, of course, in the automotive industry. We have a great blog post as well. I don't know if Jacob has it on hand, but on the heating of electric vehicle seats, which was a great kind of cross of those both applications. It's really interesting. But yeah, if any of you are going to these events, please feel free to drop it in the chat or send us an email. It'd be great to get some meetups going. We're always happy to kind of meet people in the industry. For upcoming webinars, we have an upcoming webinar on thermal performance analysis of thin film materials. So this is something really interesting. This is using a different sensor than we discussed today, rather than the MTPS, the TPS, the usual transient plane source method, but with special utilities, particularly for thin films, which is something that C-Therm kind of specializes in. We pride ourselves on. So it should be a great webinar. If this is of interest to you, Jacob's dropped the link into that way. So perfect. We are very active on LinkedIn. If you are on LinkedIn and haven't kind of noticed this is where we'll post our webinars, our kind of collaborations, any blog posts, events we're going to. I'm trying to just think. We do so much on there. Newsletters, we get share our distributors' posts and all kinds of things that way. So it's really, if you want any information of, is there going to be something more interesting to you that way, LinkedIn's a great spot for it. We're quite active. So encourage you to follow us there if you haven't already. If this has kind of interested you and you want to learn more, I know there was a lot of great pictures, especially displayed for that from the Emma Sleep team. It was great. If you kind of want to see more of this in real life, we do video demos. It was something we kind of moved toward with the pandemic, and it really worked for us, kind of having to be able to show samples being tested directly. It really is different. Just kind of seeing is believing idea, but there's a link there as well as kind of request to quote. But yeah, if you're interested in seeing more of what this does, how does the compression test accessory like work in practice, demo's a great resource for that. We do them all the time, and it's really, we're quite proficient at it that way. So with that, it's kind of the question period. So if this is where you drop off, I'll end the recording so you can ask your questions without that being recorded. But if this is where you stop watching, I just want to say thank you very much for joining us today. I know it was a bit of a shorter one, but sometimes it's pretty nice, and I think all the content was great. So thank you very much. We'll hopefully see you next time, and it was great having you. Thank you.